Good evening, everyone. So now you get a coffee-loving soil scientist. So can you show me by a show of hands how many love coffee like I do? Brilliant. So I think we're talking the same language. So I'm going to talk to you this evening about how the two loves of my life. I'll have to be honest, I love soils a little more than coffee. So I'm going to show you how these two loves of my life work together to solve two of the world's big environmental problems. Okay, so I'm going to tell you how it all started. So I'm a third-year PhD student working as part of Gallant. Gallant is Glasgow as a living lab accelerating novel technologies. So I'm part of work package 3, which looks at carbon sequestration and redevelopment of vacant and derelict land. So this land is vacant and derelict and also contaminated. So I decided I wanted to use biochar as the new technology to remediate heavy metals. But biochar is created using a source of biomass. At this point, I hadn't realized what source I was going to use. But at the same time, the Glasgow Chamber of Commerce and the Glasgow City Council had an initiative called Grounds for Recycling, which was running during the World Cycling Championships in 2023. So they had these initiatives, how it worked out was, you all know Byers Road. So they had made an arrangement with 16 coffee shops on Byers Road, and out of those 16 coffee shops, they decided for the full 20 days of the tournament, all the waste coffee grounds collected will be sent to the Botanic Gardens at the end of Byers Road. So during that time, 4.7 tons of coffee grounds were collected. This is just 16 coffee shops, 20 days in one little street in Glasgow. To put that into perspective, a small car weighs a ton. So think almost five times the weight of a small car in just 20 days. So how much do you think the United Kingdom as a whole produces in a year? You don't have to wonder much longer. On your tables, you see some little gray khaki envelopes with little hearts. So if you open them, there's a little puzzle. Please don't judge me on my crafting skills. I assure you, I'm a better scientist than I am a craftsperson. So you've got a picture on there. So that is the picture that you need to complete. You've got about 60 seconds to complete that picture to find out the number of how much waste coffee grounds United Kingdom produces in a year. If you've got so we've got 30 seconds. If you've got a figure, quickly. Surely it's not that hard. I know. By the way, for a hint, there's a hat in the middle. Put the hat first and you'll be able to figure it out. Everybody got it? Thank you. So that is 500,000 tons per year. So according to MVA Composting, UK produces 500,000 tons of waste coffee grounds a year, which brings us to problem number 1. If you think about it, that much coffee grounds, 90% of that goes into landfill. The problem with the coffee grounds in landfill is that greenhouse gas emissions, carbon dioxide, nitrous oxide, methane, other volatile organic compounds. It's a wasted resource. As we've said, you can turn it into biochar and use it for other things such as the remediation of heavy metals, but it also goes into landfill leachate, which then contaminates both our surface and groundwater resources. So we don't want it going there. But so what else can we use it for? That brings us to problem number 2. So heavy metals. A lot of you understand, heavy metals are those toxic metals that we get. Most of the sources, there's a variety of sources, some of them natural like the volcanoes, but if you notice in that picture, most of them are caused by us. So it's our problem to fix. So, and most importantly, heavy metals are not good for us or any other living organisms because they cause organ damage once they get into our water and our food systems, into our soils. So my research is looking at using the coffee grounds to immobilize them, make them unavailable for uptake by plants. So how does this work? First of all, coffee grounds as they are, they can remove heavy metals, but on a larger scale, we need a bit of modification to get them to work better. So in my case, First, I turn part of them into biochar, which is a charcoal-like substance derived from the heating of organic mass residues in an oxygen-free environment. If you think biochar, think of the charcoal. The weather's been lovely, so some of you have been having barbecues, so it's something similar to that. That's the substance. The good thing about the substance is that it's porous, and it's illustrated in that picture, that second circle there, is the pores in the biochar that makes it useful to absorb the heavy metals. So how it works. So we start off with a plant, miserable-looking plant in contaminated soils. Microorganisms don't like heavy metals any more than we do. So as you can see, there's not a lot of them, and they're miserable, and the soil is contaminated. So we add either the raw coffee grounds as they are, or the biochar. So how it works. So think of biochar or the coffee grounds as a sponge with little holes in it. And the heavy metals go into those holes. They also contain functional groups that react with the heavy metals, creating compounds that are unreactive, so they're no longer available. Also, the outer surfaces of both substrates are negatively charged. As you saw in the previous slide, the positively charged heavy metals get attached into the negatively charged, and they are held in there. So what we get is a happy plant, more microorganisms on there to work on the soil, and that's a happier looking plant. I mean, we can't all be soil scientists like me, so what can you guys do? So you can pick up those waste coffee grounds from your local coffee shop when offered. I know a lot of the coffee shops offer them now that they're no longer, the initiative's finished, they can't take them to the botanic gardens. You can put them in your compost. You can grow mushrooms if you're brave enough to do so. There's a lot of kits that you can get online that you can use to grow your mushrooms. You can spread them on your plants. You have to be very careful with coffee grounds because they're acidic. So not all plants will tolerate them. So you need to, plants like tomatoes and carrots, you can put them on those because they will tolerate the acidity. You can spread them on your flowers such as azaleas, rhododendrons, hydrangeas, and evergreen plants. And that is me. Thank you very much.